Hi students, in this lecture we are going to learn about lipid based edible films and coatings. A thin layer of an edible material that is coated on a food product to form an integral part of the food and which can be consumed along with the food product is called an edible film. In the past few years, there has been considerable amount of research on edible coating due to its properties of shelf life extension and also since it is a form of eco-friendly packaging. They significantly reduce the generation of packaging waste and also reduce environmental pollution since they are mostly produced from renewable materials like bio-based polymers obtained from biomass or microorganisms. Edible film forming materials can be proteins such as casein and whey or polysaccharide like starch or cytosine or lipid materials like waxes. Lipids are hydrophobic substances with the specialty of limiting moisture barrier within the food product. The most commonly used lipid based film forming materials are waxes like beeswax and paraffin wax, lacs or lacquers, acetylated glycerides, fatty acids and alcohols among others. These materials may have varied barrier efficiencies due to factors such as length of the hydrocarbon chain, chemical composition of the molecules like the presence of polar molecules and the amount of acetylation and unsaturation present in the chain. Objective of this lecture is that to gain detailed knowledge on the different lipid based edible coating materials and their applications. To understand the moisture barrier properties of the lipid based edible coating film. Let us discuss about lipid based edible films and coatings in detail. Lipid based edible coatings may contain acetylated monoglycerides, natural wax and surfactants. Lipid coating materials are efficient barriers to transport of moisture due to their properties of relatively low polarity, but since lipids possesses the property of hydrophobicity, they form thick and brittle films. Therefore, composite films associating the lipids with the proteins or polysaccharides are developed. Polymer structure matrices like polysaccharides are used to support the hydrophobic materials in order to improve the strength of the film. Waxes like paraffin wax and beeswax are considered the best among the lipid materials for coating. In some places, the corks on the wine bottles are coated with beeswax and paraffin wax, which prevents the cork from getting soaked in wine and also prevents the consequent release of compounds from the cork to the wine, affecting the quality of the wine. This can be effectively used in place of plastic corks in wine bottles. In confectionery as well as bakery industries, cocoa butter and cocoa based films are used. Lipid based edible coatings are also used in dry cereal based products since they prevent the possible flavor and water loss from the fat in the product and also from any aqueous stuffing. In pharmaceutical industries, food grade lacs and varnishes are used for coating active substances. These are extensively used in the food industry to improve the surface properties like color or shine and to reduce the surface stickiness. They are also nowadays used as protective coating for various food additives. Fish or meat products uses emulsifier or surface active agents like lecithins, mono and diglycerides, mono and diglyceride esters, fatty sucrose esters, fatty alcohols, fatty acids, etc. for coating since they act as barriers to gas or moisture transfer. Coating formulations also include them since they can improve the surface adherence between the film and the food product. Let us discuss different types of lipid based materials used for preparing edible films and coatings. First one is wax. Paraffin wax is obtained as a fraction during the distillation of crude petroleum. It is made up of a mixture of solid hydrocarbon which is formed by ethylene catalytic polymerization. It can be used for coating on cheese and raw fruits and vegetables. The other waxes used are carba wax, which is an exudate obtained from palm tree leaves, beeswax produced by honey bees. Candelia wax is obtained from Candelia plant. Waxes can have an influence on two important aspects of food, which are forming a barrier for gas and moisture transfer and improving the surface appearance of the food by adding a shine or gloss on the food. They must be removed before consumption if it is applied as a thick layer on the food, or else if it is a thin layer, it can be consumed along with the food product. Among the edible coating material, waxes provide the most efficient humidity barrier. Next lipid based material is acetoglyceride. These are produced by the acetylation of glycerol monostearate when it reacts with the acidic anhydride, and these acetylated monoglycerides possesses the unique property of solidification to form a flexible wax-like solid form from its original molten stage. In their solid state, most lipids can be stretched to only up to about 1 or 2% of their original length before they break. But acetoglycerides can be stretched to about 800% of its original length. With the expression of methyl or ethyl cellulose, these films have much less water vapor permeability than that of polysaccharide films. They are generally used on meat to retard the loss of moisture during the period of storage. The last one is Shellac resins. The insect Laccifer leca secretes these resins, which is a complex mixture of aliphatic alcyclic hydroxylic acid polymers. It is soluble in alcohol and basic solutions. It does not fall under the category of GRAS substances and can only be used as an indirect food additive in coating formulations and adhesives. There has been only a few researchers on the use of shellac resins in food. It is mainly used in pharmaceutical industries. These resins as well as their associates are used as coating materials for various fruits. They can impart a shine to the fruit which attracts the consumers. They have varied effects on gas permeance but protect the fruit by blocking the openings in the peel of the fruit. It is seen that citrus fruits which are coated with shellac and wood resin based coating generally possesses lower internal oxidation and higher internal carbon dioxide, as well as ethanol content in the fruit will be considerably higher than in the fruit coated with wax coatings, which is an indication of off flavor. Sometimes the prevalence of post-harvest pitting is increased by shellac and wood resin based coating. The very important thing in lipid based edible films and coatings is composite edible films. Let us discuss few points about that. Edible films and coatings can also be formed by combining two different types of materials, thus forming films of heterogeneous nature. Films can be a blend of pure lipids with other materials like proteins, polysaccharides or their derivatives, and this can be done either by adding the lipids to the solution of film forming hydrocolloid, which is called the emulsion technique, or else the lipid layer can be deposited onto the surface of an already formed hydrocolloid film, and this is called bilayer. When materials other than lipids like sugar crystals, fibers and proteins are dispersed in lipid materials, fat dispersions are formed as seen in chocolates. Composite edible films are mainly used to improve the mechanical properties of a film when used for specific applications. Each component of the film contributes to the functionality of the composite film, mainly barrier properties as well as the mechanical strength of the film. The bilayered films often offer same barrier to moisture as pure lipid films, which is many times higher than that offered by the emulsion based films. However, hydrophilic nature of the hydrocolloids may result in the probable absorption of water by the film when kept in direct contact with any moist phase. Also, bilayered films have additional processing steps like casting and drying, which limits them from being used in many commercial productions requiring high speed. Cellulose ethers are mostly used in composite films, but materials like pectinate, cytosol, starch and alginates are also used in the formation of composite films, popularly in combination with stearic or palmitic acids, beeswax, acetoglycerides as well as lecithins. Additives are having important role in edible films and coatings. We will see about additives now. Substances that can further improve the functionality of the films like flow and spread properties, improving the adherence of the film to the food product, etc., have also been added to film forming solutions. Texturizing agents are used to improve the texture of the film. Protein solubilization can be improved by the addition of acid or alkaline substances, and dispersed systems can be stabilized by the use of emulsifiers. Also, the basic properties of antimicrobial agents and antioxidants are better appreciated when incorporated into the coating solution than their direct application, since this promotes slow diffusion of the active components from the food surface. The solubilization of biopolymers can also be increased by the addition of enzymes. Polymer gelation in alginates or pectinates can be promoted by the addition of some salts. Low molecular weight non-volatile plasticizers are added to improve the flexibility properties like less brittle and tougher film. Basic nutrients and nutraceuticals can be added to the film to improve the overall nutritive value of the food. Compound can also be added to the film forming solutions to improve the sensory properties of the food product. Let us discuss few points about the different barrier properties of the edible film one by one. First, we will discuss about mass transfer within the foods. The organoleptic, microbiological, nutritional and functional properties of a product are determining factors of quality of the food. If the food is not stored or distributed properly, these properties can get affected mainly due to transfer of moisture out of the food to the environment or migration between the various component parts of the heterogeneous food product. Preservation aims to protect the food from the environmental conditions as well as to control mass transfer and water loss in order to maintain the quality of the product. Food packaging is one of the main techniques that can preserve food by controlling the transfer of mass between the food and its surrounding environment. Major packaging materials commercially available are plastics, which are effective means for protecting food from its environment but have less effect on the mass transfer occurring within a heterogeneous food system. The main parameters that affect the moisture migration within or throughout a food product include water activity differential as well as the solubility and diffusivity coefficient, which represent the thermodynamics and kinetics of the system respectively. Whereas moisture transfer between parts of the food having different moisture levels depending on the solubility and diffusivity coefficient alone. Therefore, controlling these two parameters is essential in order to control moisture transfer. Applying a thin layer of barrier between the parts of the food having different moisture levels is an effective way of modifying the migration kinetics. Edible films and coatings can be used to form these barriers against the transfer of moisture, therefore qualifying as a type of packaging technique. These coatings are applied between the different parts of a heterogeneous food system irrespective of the moisture or temperature differentials. The efficiency of the coating may vary according to the composition of the coating material, the nature of the food product and the method of film application. Next important barrier property is water vapor permeability. Lipid based edible coatings are the most efficient coating material in terms of moisture barrier efficiency. Among them, animal and plant waxes offer the least water vapor permeability, and while fatty acids and low melting point fats have highest water vapor permeability. Lipid based edible coating materials in their increasing order of water vapor permeability are as follows: high melting point wax, resins and natural lacs, esterified mono and diglycerides, fatty alcohols and emulsifiers and surface active agents. At 25 degrees Celsius, water vapor permeability values for paraffin wax and beeswax are 0.02 and 0.06 into 10 to the power of minus 1 gram per meter per second per Pascal. The permeability values for some lipid based edible coating substances are almost similar to those of the plastic materials like low density polyethylene or polyvinyl chloride. Lipid materials which have a high percentage of fat composition have a low permeability value than those of the liquid materials. However, due to the brittle nature of most solid lipid based films, they are generally formed into a bilayer or emulsion films in combination with hydrocolloids. The preparation technique of the film has an effect on the barrier properties of the film. Bilayer films have similar barrier efficiency as that of the films composed of pure lipid or plastic, but they have lower efficiency than the films of emulsion type. Emulsion based films have permeability values similar to those of films composed of starch or proteins. The composition of the film and its structure and its properties like temperature, relative humidity and pressure, which are based on external conditions, have an effect on the values of water vapor permeability of the film materials. The physical and chemical properties of the substance passing through the barrier also affect the moisture transfer. The last one is effect of film composition. The low water vapor permeability of the lipid based edible film material is due to the fact that lipid materials have less affinity towards water. However, the different lipid based edible materials will show different values for moisture permeability as a result of their varied nature. Waxes have high amount of long chain fatty alcohols and alkanes, which gives a highly hydrophobic nature. Therefore, waxes are considered high efficient as packing materials in terms of moisture permeability. Beeswax is considered the most efficient among them. Efficiency can be determined on the basis of the hydrophobic nature of the materials, which affects the material interaction with water. The hydroxyl group of stearyl alcohol has less affinity for water than other functional group, which imparts more hydrophobic nature. Chain length has a major influence on the barrier properties even if the compounds have similar chemical nature. The polar nature and the varying crystallization probabilities of unsaturated fatty acid shows that they are less suitable for controlling the transfer of moisture as compared to saturated lipids. The physical state of the material also has an influence on the moisture transfer properties of the film. It is seen that the value for permeability increased 100 times when paraffin oil content increased to 100 from 75%. Solid lipids are denser than liquid ones and therefore there is limited migration of water. This is also the reason for reduction in solubility of water in solid lipids. However, structural defects can be caused in film if the composition of solid fat in the film increases beyond a critical limit and this can lead to the negative effects on the permeability values. The affinity of the coating material towards water depends on the chemical nature of the components of the film, while the structure of the film depends on the physical nature of the components. Now, let me summarize the points so far discussed in the given lecture. First one is, edible film forming material can be proteins such as casein and whey or polysaccharide like starch or cytosine, or lipid materials like waxes. These materials may have varied barrier efficiency due to the factors such as length of hydrocarbon chain, chemical composition of molecules like the presence of polar molecules, and the amount of acetylation or unsaturation present in the chain. Second one is, lipid based edible coatings may contain acetylated monoglycerides, natural wax and surfactants. Lipid coating materials are efficient barriers to transport of moisture due to their properties of relatively low polarity. Waxes like paraffin wax and beeswax are considered as the best among the lipid materials for coating. Fourth one is, edible films and coatings can also be formed by combining two different types of materials, thus forming films of heterogeneous nature called composite films. Composite edible films are mainly used to improve the mechanical properties of a film when used for specific application. The last one is, lipid based edible coatings are the most efficient coating material in terms of moisture barrier efficiency.